Today, we're going to be looking at dictionaries and CSVs in Python. And these are two fundamental concepts when you're starting to work with larger data sets that are very handy to have at your disposal. We'll be able to take on new kinds of problems in much more straightforward and logical ways. So let's jump right in. First, we're going to open looking at dictionaries and talking a little bit about how they compare with lists, which is another kind of data structure. So dictionaries are kind of like lists in that we can store many values in them, but the way that we store them is different. We like to think of dictionaries as lookup tables, but we'll get to that in just a moment. And then we're going to turn our eyes towards reading CSV files. These are data files that you can think of kind of like a way of storing a spreadsheet or a database that's easy for people to share. And many public data sets are shared as CSV files. So we'll get some fundamental exposure to CSV files, which we'll be using in upcoming exercises and projects. Couple announcements before we get into today's main content. First, the reading that went out at the end of last week is a few pages of a Nature article. We're not asking you to read the entire article or all of the details on the methods because they get pretty involved. This is a first-class, top-tier research paper in Nature Human Behavior. And because of that, when you start reading research papers of this caliber, they are often obtuse. And so if there are words that in methods that don't make sense to you, that's okay. They probably didn't make sense to me either in many of the cases. What we're looking for is sort of the broad strokes of how they went about this research. And we'll be reproducing parts of it in the next project. We'll be looking at how they did the hit rate and test, which was about searching and the outcomes of searches in police stops. So there's a few questions, true, false mostly, that are due tomorrow night. This is a pretty quick reading. Otherwise, if you're moving through with these questions, and these questions can help guide you and make sure you're understanding the premise that the paper is establishing. Quiz 2 will finish up grading and be released later today. If you felt like Quiz 2, and if you look at over your work and you're wondering how some diagram was supposed to be followed through, do watch Kaki's review. It's been posted to the course site. It was last Wednesday, and you can see the recording on Zoom. Sign in with your SSO. And if you want to talk specifically about something that you thought you were doing correct, or someplace where you want to clarify your understanding, please do stop by tutoring. We'll have tutoring in the evenings as usual this week. Quiz 3, I'm happy to report, is 3 weeks away. So we've got some nice breathing room between now and then. It's on April 1st, so it should be a fun quiz. All right, we're going to start. There's one other announcement I wanted to make. A peer of yours in the class submitted a suggestion on our feedback forum saying, in other courses, it's common that when you're in a lab in the sciences that you might be given some best practices on how to practice healthy habits. And we should do that in COMP110 too. We're spending a lot of time in front of our keyboards and programming. And I thought this was a fantastic suggestion, and the TAs ran with this idea. So what I would encourage you to check out, if you're looking for some tips on healthy habits in computing, under the resources page, under tips and tricks, you'll find a link to healthy computing habits, ranging from vision and your posture. So posture check, are you sitting up straight? To how you're, arranging yourself around your keyboard, trying to keep your arms at a 90-degree angle, not have the screen too close or too far away. These kinds of tips and tricks you can find on this page. I thought that was a fantastic suggestion, so thank you for that. All right. Let me just take a look. I saw a few questions come in. And I'm not sure what the survey is about. We will have a survey going out soon. So be looking for that. I think on Thursday, we'll have a mid-semester survey where you can provide some feedback on how things are going with sync, async, and all that. And we can look for that on Thursday. All right. So dictionaries are another kind of data structure that we have available to us in Python that will make some problems much, much easier for us to solve and to model in our programs. So what's an example of this? Well, let's jump right in to a type of problem that would be kind of cumbersome to model in our program. Let's say we wanted to record or keep track of players' names so that we could make it easier to look up what is their jersey number. So you can imagine a table where we have something like the player, and we want to relate with that player's name their jersey number, right? So, just making up some names here, I could imagine, Brooks is the name of a player, and Brooks has a jersey number 15, right? Baycott is the last name of a player and has a jersey number at 5. And Love is the last name of a player, has a jersey number of 2. Now, when we think about this type of a table, that makes it easy to go from looking up a player and asking, okay, what is the number of some player, and being able to quickly determine their jersey number. This would be pretty cumbersome to try and model in our programs as we've written them so far, right? Because lists are organized by indices that start from 0 and work their way up. So you could maybe imagine having 2 lists, right? One is a list of players, another is a list of jerseys, and they're organized in the same way, right? So at index 0, Brooks in the players list would be there, and in index 0 of the jerseys list would be 15. And maybe you could go and find, well, what is the index of a player in the names list, and then go look for that same index in the jerseys list. It turns out that's pretty cumbersome and in fact very slow, but this is a common kind of problem that you'd like to have in your program and be able to model. And you might be thinking, well, Chris, why not just use constants? And in this case, if we knew all of the players and the numbers that we wanted to model in our program when we were writing the program, constants would be fine. But if you're making a game where you want to have a leaderboard to keep track of an arbitrary number of players and have their name associated with the number of points that they have, you wouldn't really be able to use constants there. You'd have to have something else. So the reason we have dictionaries, one of the most pressing reasons we have dictionaries, or the primary reasons, is to model lookup tables. With more flexibility than lists. Right? Because lists are pretty limited. We have to index each item of our list by a number. It has to be in order starting from 0, right? It's just, lists are really made for sequential items. But oftentimes we want to have tables that allow us to say, okay, I want to associate the name Brooks with the number 15, or the first person playing my game with their score, right? So another reason that we have dictionaries I've already mentioned, which is oftentimes when we want to have the ability to mutate or to add additional entries to something like this table, we can't use just constants, and it becomes pretty cumbersome if we have to keep track of many different lists. So dictionaries make it easier to have mutable key value pairs. So you're going to hear me say the words key value pairs, and I'll come back to describe what this means in more detail soon, right? But the gist is the key is what we're looking up by. So the name of the player in this example, and the value is what's associated with that key. And if we used constants, as I mentioned before, as our keys and their values, well, that's not something that's supposed to be mutable. We can't add new constants to our program. So if we picked up a transfer mid-season, we would have to go and rewrite our program, right? And the third reason is that we have very fast lookups for specific items, or I should say specific keys. All right. As I mentioned, we could do this with two lists and just have the names of the players in one list and in the same order, their jersey numbers. First, go figure out what position is the player's name in, then go look up the jersey number in that same position. But that's pretty slow, and it takes, as you can imagine, looping through all the names in one list and then looking it up in another. In the next course, COMP110 data structures, you'll learn all about how dictionaries and lists are implemented behind the scenes and under the hood. And you'll get a sense that if you're looking for specific keys, in this case, if you wanted to find Bacot's number, it would be very quick to look up and very efficient computationally. So there are a number of reasons why we want to have dictionaries, and let's talk about how we actually make use of these in our programs. All right. So one question that just came in is, are dictionaries limited to 2 columns? That's a great question. And the short answer is yes, but by the end of today's video, we'll see how we can actually think of storing or modeling tables that have many columns using the combination of both a list and a dictionary. Great question. The attendance poll for today is effectively working through the Gradescope question. So there are some Gradescope questions to follow along with for today's lesson that will open, should be open for the first section and will open before the second section begins for it. Okay, so what is the dictionary and how do we actually model this in Python? When we think about what a dictionary in the real world is, we think of it as, some term, such as, say, the string dictionary. And I'm going to put quotes around this. And that term is associated with some definition of it. And in this case, the definition of a dictionary is a mutable key value data structure. All right. And I'm going to put some curly braces around this as well, because this is what we're going to learn. This is a dictionary literal in Python. I'm going to put a comma after this entry and say, a key is defined as something you look a value up by. And what we're seeing here in this syntax is actually a Python dictionary that is associating strings with other strings. And that's how you would think of a dictionary in the real world, like the object of a dictionary that you could find at a bookstore. And so if I were to highlight the key, these are the keys, and their values are the associated, what we would think of in a physical dictionary as their definitions. But in computing, we tend to call these just values because it's not always necessarily a definition. Sometimes it's just an association, like a player's name with their current number of points. The definition of that player isn't their number of points, but the value that's associated with their name is what you would think of as the value in a key value store or data structure. Right. So as we've learned, so this is an example of a dictionary literal. Well, how would we actually specify the type of a dictionary? We've seen like a list. When you say that you have a list of integers, you'd say list and then square brackets, the int. Well, here we've got keys and values. So we're going to have 2 types. So let's demonstrate how you would specify the types. So the type of a dictionary is the keyword or the type name dict, D-I-C-T, and then in square brackets, you're going to have the key type, and actually I'm going to color code this in just a second, and the value type, all right? So in this example, we would have a dictionary whose key type is a string and whose value type is a string, right? And so if I were to highlight this real quick, the key type is going to be whatever type we're saying, okay, this is what we're going to be able to look the values up by. And then our value type is going to be the whatever we associate with a given key, right? And so In this example, we've got a string to a string, which is how you'd think about a dictionary in the real world. We're associating a word with its definition. But if you can imagine, player name with their number of points, or what if we wanted to go in reverse, a player's jersey number with their name, we could use a dictionary that has keys of type str and values of type int, or vice versa, right? So you've got a lot of flexibility there. And in the previous example with the jersey numbers, we could have thought of that as a dictionary of string to int, right? Oops, let me go back to pen here. So this is a dictionary where you'd have a string and an int, right? So the string is specifying the type of the key, and the int is specifying the type of the value. All right, let me look for questions here real quick. So does it associate keys with values or values with keys? That's a great question. We're primarily associating keys with values. And that gets a little bit ahead to another point that I wanted to make about dictionaries, which is the keys have to be unique. So in our example, it would break down if we had two players who have the same last name, we wouldn't actually, without maybe adding their first name as a part of the string, be able to differentiate between them. And you can, when you have a dictionary, your keys have to be unique, whereas you can have duplicate values. And so if you had a score table, right, where you have players' names and everyone starts with a value 0, that'd be fine, but you can't have two players with the exact same name if you used a dictionary in that way. All right, before we come back to just some notes on syntax, let's actually try setting up an example in code, and I would encourage you to follow along with this. So let me close this example here. And I'm going to set up a Python file named ls17 underscore dictionaries.py. Right? And let's just add some example of dictionaries as our doc string. All right. So why don't we start with the example we previously laid out. We could have a variable named players. Its type would be a dictionary where string values are associated, or sorry, string keys are associated with int values, right? And we can have an empty dictionary literal. So let's make some notes here. Establish a type with dictionary key type, value type, right? So the key type comes before the value. So we're saying this is a dictionary of strings to integers, and empty dictionary literal is just the curly braces with nothing in between them, right? So let's add some new entries. Let's establish some key value pairs. So we like to call this operation inserting or putting a key value pair into a dictionary. So insert a new key value pair. So players, and here's where things are going to look kind of familiar, but also be a little bit different, right? Brooks is assigned 15, right? So notice we're using subscription notation here, just like we used with lists when we're trying to access something by their index. But in this case, this is a string. This isn't an integer, and this is the key, right? So let's maybe make a note that reference keys inside subscription notation, values are assigned. All right. And what we've just done is we've added a new key value pair where now the key Brooks is associated with the value 15. And we can do this with the other players as well. So love is assigned 2 and Bacon is assigned 12. All right. Oops, 5. All right. So we've established these key value pairs. What can we do with this? Well, we can try to print out our entire dictionary. And so if we were to print this dictionary, what we would see is Python's dictionary literal representation of this as a string. So if we were, let me try just running this real quick. Python m lessons dot, oops, and I got to save my file here. ls17 underscore dictionaries. And we see that dictionary literal representation. We have strings as our keys. And what we'll talk about the syntax a little bit more specifically shortly, but the colon is separating in the key and the associated value. And then the rest of them are separated by commas. So these are our key value pairs once we've established this dictionary. Notice that we're adding these after initially constructing an empty dictionary. We're able to add new entries to it. We're hard coding these entries in, right? We're writing this out, but you could imagine asking the user for their name as an input, and then their player number. And we could keep adding players to this dictionary when the program runs without knowing, who the players are. Let me check for questions here. All right. Do the declared keys and values have to be in the same order types within the square brackets after dictionary? Yes, so the order is important here. This is a great question. Your key type is always going to come first, and your value type is always going to come second, right? Maybe that's worth making a note of. Key type always precedes value type. And this is how we know which is which, right? Because in just a minute, we're going to make a dictionary that goes the opposite way, that would make it easy to look up a player's name by their number. But in this case, we've got a dictionary that makes it easy to look up a player's number given their last name. All right. Let's see. Can keys and values be any format? String, integer, and Boolean? Yes. So this is one of the reasons why dictionaries are really cool. We can have keys of any type that we want. There are some constraints to this, but all the types that we would think we would want so far, you could use. String, integer, you can even use a float. And then our values can also have a lot of flexibility. They can be any type as well. So this is one of the reasons why we have these as opposed to just using lists. We have more flexibility in what we're able to look up the values that we store in this by. Can you have a dictionary with mixed types? Yeah, so this is an example of that. I think maybe this question is asking, can you have mixed types of values? For now, we're going to think about our values as homogeneous. There are cases where in the real world, you might see a dictionary where your values can have many different types. We're going to intentionally try and avoid that because while it might be easier to establish a dictionary like that by putting anything you want into it, the code that you have to write becomes more cumbersome to actually process it because you have to be very careful that when you go and work with a value, you're using the right thing. So for right now and for our purposes, and this is true when you go on into data structures, the next course as well, we're going to constrain ourselves to say, within a given dictionary, our keys are going to be one type and our values are going to be another type. Now, this isn't to stop us from having many different dictionaries that have many different types and mapping between them. But for our purposes, we're going to keep our values a single type. So what makes us more valuable than more flexible than lists? The first thing that we've seen so far is that we can actually index and look up by these strings, right? So this is something you couldn't do with a list. A list, the very first item in that list had index 0. The next one had index 1. So here we can actually create these little lookup tables. And we'll see something else in just a moment that makes it a little bit more flexible than a list as well. All right. How would we update these values if this were scores? Great question. Well, it works. Let me give you an example here that's a little bit silly. This is intentionally off by 1. So what if we had, if this is a kind of a silly example, but what if we had a player score and wanted to be able to increase the value stored for that player? Well, it's a lot like any other, list assignment or a variable assignment. We would say, Baycott is take the current value and add 1 to it. We could also make this more explicit to say players Baycott +1. And it works as you would expect. This is going to replace the value that's associated with Baycott by taking the current value associated with Baycott and adding 1 to it, right? So you can modify it as a mutable data structure. You can add these values to it. Can you change the order of your keys? This is a great question. Generally speaking, when you're using a data structure like a dictionary, you probably don't want to depend too much on how you think about the ordering of your keys. Python is actually kind of unique and different from many other programming languages in that it does remember the order that you added key value pairs into your dictionary. So you'll see in just a moment when we loop through these keys using a for-in loop, it's going to give us back those keys in the same order that we added them to the dictionary. More generally, we try not to think about our keys as having some specific order to them. And most languages that have comparable data structures actually don't allow you to make the guarantee that it retains the order that you put them in to your dictionary. So typically when you want to have different orderings, like let's say we wanted to be able to sort by a player's name, we would take all the keys, put them into a list, and then sort that list, which is a sequence and has a specific order. And then we could go look up the values in our dictionary in the order that we had just sorted. But otherwise, you're typically not going to rearrange the ordering of keys within a dictionary. Good question. All right, so let's try looping through each of these players. So for in loops, we'll give you each key one by one, right? So I'm going to say for player name in players, right? Maybe what we'll do here is we'll print and use an F string. And what I will say is player name is the key that is mapped to the value players. And we're going to look up in this dictionary player name, right? So this is a for-in loop like we just learned in the last segment. And we can name this variable whatever we'd like. I called it player name. I could have named this key. When we use a for-in loop with a dictionary, by default, it's going to give us each key one after the other. And as I mentioned in Python, it's going to give us those keys in the order that we added them to our dictionary, right? And then once we have a key, well, that's just a string value we can use, but we can also go and look up the associated jersey number by using the subscription notation like you see here. So let me just try running this example real quickly. And notice that we looped through each of those values. Brooks 15, Love 2, and Baycott. Notice we did, we initially started it at a value of 4, and then we increased it by 1. So Baycott at the point of running and evaluating this for loop is 5. Values do not need to be unique in your dictionaries. And the reason for that is imagine, scores at the beginning of a game. If you used a scoring table, for example, you would want everyone's scores to be 0, but the keys do have to be unique. Like we saw here, we don't have 2 keys Baycott. We have 1 key that we can associate a value with. So the keys are unique, but you can have duplicate values, and that's no problem. All right. So I want to get back to this question that was asked earlier of the flexibility versus loops, versus lists. Dictionaries versus lists, what do you gain? How are they a little bit more flexible? Well, let's imagine we wanted to have a table that looked up in the opposite direction. For example, we would have, let's say jerseys, and is going to be a dictionary where the key type is an integer and the value type is a string. And here I'm going to go ahead and set up a dictionary literal so we don't have to insert these items one by one. What if we wanted to just specify these as a dictionary literal, like we've seen string literals and lists literals? Well, we put those curly braces and now we give our key. So let's say 15. And then the associated value is separated with a colon. So 15 is the key 15 is associated with the value Brooks. The key 2 is associated with the value Love. key 5 is associated with the value Baycott, right? And we should probably make a note of this, what this is giving us here. So you can have keys and values of any types. Notice this is the opposite mapping, or I could have said inverse mapping that we had above. Additionally, this is an example of a dictionary literal, right? Okay, so we have these jerseys. If we wanted to have a little fun with this and imagine, a dream team here, we could say, jerseys at index or key 23, I should say, is assigned Jordan, right? And here's another place where you have more flexibility than you do with lists. With lists, if you wanted to add a new item to your list, you needed to append it. And the index that was associated with it was, whatever the next number was, the current length of the list, right? So here, the index would have been 4 if we had a list of names. And oftentimes, even in this example, here's an example where we have an integer that we're using as our key. But wow, isn't it nice that we can add a key value pair without having to have all of the numbers between 0 and 2 and then 5 and then 15 having it would be pretty annoying if we needed to have 24 entries in our dictionary in order to store these 4 players associated with those numbers, which in a list you would kind of need to have if you wanted to use a list and use the number of the list or the index of the list as the jersey number. So with a dictionary, we can effectively have only the keys we want. And if our keys are integers, that means we don't have to have them in consecutive order and covering the entire range. We can prove this to ourselves by printing the jerseys dictionary here. And notice there's Jordan that's been inserted into this dictionary. And when we print an entire dictionary, we get this dictionary literal representation. Good question. Going back up to this for in loop, don't you have to define player name? So remember, with a for in loop, the name of the variable that we have here is implicitly associated with whatever the item type that we're iterating over is. So in this case, player name, we know is going to be a string because when we use a for in loop with a dictionary, we're looping through the keys, and those keys are string type. You can't actually specify in Python, a for in loop where you specify the type of the key. It's always implicit when you're using a for in loop, but you don't have to specify or declare this variable otherwise. So you wouldn't have to say player name stir here, right? With a for in loop, that type is inferred for you automatically, no problem. In this, how does it know which one is the key and which one is the value? That's a good question. In this for in loop, how does it know which is the key and which is the value? I love this question. So let's try and make this maybe a little bit more explicit here. So the way Python is made, the people who wrote the programming language decided when you use a for in loop to iterate over a dictionary, each time your for loop iterates, this value is going to be the next key, right? So player name is always going to be the key, but if we wanted to, we could say that, the key is the string that is player name, right? And we could also say that the value then is the integer, and that is the player's dictionary, and we're going to look up that key, right? And so these are two ways of saying the same thing, and then, I could have printed those values alternatively, right? So f string key, and then value, right? So notice there's no real difference between accessing player name, which is the next key, the next key, the next key, each time this for loop iterates, and then looking up in our table. So the way that you look up in a dictionary, look up in your table, is you say the name of the dictionary, and then in the square brackets, whatever the value of the key is. And so this player name first would have been Brooks, and then Love, and then Baycott. Why were the keys and values associated or assigned one by one up here and as a literal down here? Great question. And the reason for having both ways is because this is a handy, when you have a literal, like we have here, a dictionary literal, it's handy when you know all of the values that are going into your dictionary as soon as you make it. But remember, you might not. And in most programs and in most uses, you won't actually. So this is just a shorthand for being able to do it in the cases where you can. Most of the time, you're going to see that you wind up assigning key value pairs one by one. Or we'll look at an example where we read a file and add new entries based on the content of that file. So even though this is a string, this could have been, a variable name that we ask the user for their name and then also their player number. And you would have needed to do it like this if you wanted to have a loop that could add as many players to your game with scores or jersey numbers as you wanted. All right. Is each key value in its own index? Yeah, you can kind of think of the key as the index. If we go back to this example, this table that we set up, would have looked a lot like this table here. And in fact, when we get to trying to model these in our memory diagrams, the way that this would have been a dictionary, and we would have just written the type of this dictionary up above, a dictionary string int. So we would have actually put this, in the heading of this table, and this would have been how we represented it in memory. And so even though the word index has some kind of special meaning in computer science, that means that implies there's a special arrangement in memory for how these things are going to be arranged. So we don't call these keys indices. Brooks isn't an index necessarily, but for our purposes in COMP110, it's okay to think of it as an index because it's very similar. It's what we look a value up by, right? But these, we would technically call them keys. And yes, per single key, we can have any value we want associated with it. Can the for in loop iterate over the values that are stored in your dictionary? So in a sense, if you can loop over the keys, that's how you loop over the values. There are ways of accessing the values directly as a set that are a little bit beyond our concerns. But if you were to search for, looping over or iterating over values of a dictionary in Python, you would find examples of how to do that. But can you access a key value pair by its index? The fourth pair of the dictionary would be Jordan. So yeah, in this example, if we wanted to actually say print, well, what is the jerseys of 23? What is the value associated with the jersey number 23? In this example, if I were to run this, we would see that Jordan is associated with the integer 23. 23 is the key, Jordan's the value. And in the first example, we could have printed players Brooks to figure out that Brooks's jersey number was 15 in that example. Now, if you're asking, could you go the other way? How do we ask for players, the value is 15. How do we know that Brooks is associated with that? That's not easy. You'd have to loop through all of your keys to figure that out. So this is a one-way mapping or a one-way relationship from keys to values, right? Just like a dictionary, the words in a dictionary, this is a one-way relationship between the word that's being defined and what it's associated with. So you do not have to use a pen with a dictionary. That's right. So you can actually assign directly to keys, and this is inserting, or you could think of it as appending a new entry to a dictionary. With lists, you had to use append, right? You couldn't use the index of the next item and it automatically worked. You would get an error. But with dictionaries, the expected way of inserting a new key value pair into it is by accessing it directly. You don't have to use append or any other special method. How do you remove a key? Great question. I should have mentioned that. All right. Well, let's say we wanted to remove Jordan from this dream team because it doesn't really make sense to have Jordan on it. Well, just like we can pop values in a list, we can pop values in a dictionary as well. So I'm going to set up a variable here to demonstrate pop doesn't only remove the item, it actually, this method called returns it. So I'm going to name this popped name is a string. And so we would say jerseys.pop 23. And now if we were to print the popped name and then print the jerseys once more, and I'm going to go ahead and add some notes here. What we'll see is that the pop method allows you to remove a key value pair by its key, right? So again, we always think of these operations in terms of the keys. We associate with a key, we can remove by the key, we can update the value associated with the key. That's the high order bit here, the important parts. The pop method returns the value associated with the popped key, right? So our little program here is going to pop off on Jordan. Sounds right. And so I should have maybe printed, so the last two lines to print here correspond to these two print statements. So the player that the value that was popped off of this dictionary was Jordan. And if we printed that dictionary, what is in the jerseys dictionary after popping, we would see that it's only the 3 players. So you can remove key value pairs from a dictionary as well. Great question. Is there any built-in function that flips the relationship so you can go in the inverse? I'm not certain, but I'm going to speculate to say that even if there were, you would have to be very careful about it anyway. As I mentioned, you can have duplicate values, but you can't have duplicate keys. So if you flipped, let's say you had a players table with players and their scores, and everyone had the score of 0 to begin with. If you inverted that, there's only going to be one entry left, right? 0 is going to be associated with, I guess, the last player as part of the flip algorithm. So I'm going to speculate to say that there's not a built-in way of doing this. And if there were, you would want to be terribly careful using it anyway. And in most cases, you're going to need to apply the logic yourself. And it's going to be up to the problem that you're trying to solve to decide what happens when you have the case where there's duplicate values. Does this create an error? Do you just override and use the last one? And this is going to depend on the problem you're trying to solve. Dictionaries seem so easy to use. Why would you ever use a list? Great question. In computer science, and especially in the next course, when our problems start to become much larger than we've solved so far, and we're about to get there. We're going to be doing some data analysis on a much larger data set than we've done previously this semester very soon. We tend to choose data structures like lists and dictionaries based on some of their characteristics. And there's a lot of convenience, as we're seeing, in using a dictionary. But one of the things that's really excellent about a list is that when you're trying to process every single value that's in a list, it's much faster algorithmically to be able to do that in a program than it is to process every key value pair in a dictionary. The reasons for this are a little bit beyond what we need to concern ourselves with here. But the gist is effectively, lists are in the way they're going to be organized in memory is just one after the other, after the other, after the other, every value. Whereas dictionaries, the way they wind up being implemented behind the scenes is we're going to use a lot of space and we're going to be clever about how we organize the relationships between these keys and values in memory. And that makes it very fast to look up individual items and to insert individual items. But when it comes to wanting to write an algorithm that processes, every single element or key value pair in a very large dictionary, it's more expensive computationally and slower than using a list. And when you have enough data, that extra cost is actually pretty significant. It's the difference in your analysis taking 30 seconds to wrap up versus 3 hours to wrap up once your data set's large enough. But that's really the concern for the next class. The gist is when you have items that are sequential in nature and data that's sequential in nature, all you care about is the rough ordering. Lists tend to be more efficient than dictionaries, but you're right, the dictionaries are pretty handy to have at your disposal. Why can't you have duplicate keys? Well, That's a good question. If you really needed duplicate keys, you could imagine having your values be lists and having multiple values associated with a single key. But for reasons that are, there's a problem with ambiguity. When it's ambiguous, what value would be associated with a key, right? So what would happen if we had two values associated with Jordan? Which one are we talking about? Do you pick one at random? Do you give them both back? Well, if you expected to get two values back by looking up a single key, or that for the problem you're trying to solve, you could do something like that. And this is a little bit beyond our scope, but I think this is such a valuable question. Let me give you an example really quickly where we'd say, we could have a dictionary where the key value is type int, and we could have a list of strings as our value type. So we can actually compose these two ideas. We can have a dictionary where the values are lists, and then we could associate many values with a single key. But this is a little bit more complex than having, duplicate keys leads to ambiguity that would be very difficult to resolve. All right, great questions there. And now that we've seen dictionaries, let's go look at another way we might use them by processing what are called CSV files or comma-separated data files. So I actually want to give you an example of one of these with a very simple CSV. And let me just show you this really quickly in my file explorer here. So you see this file, I apologize for the small font here, but I'm calling this file weather demo. And if I were to open it, you'll notice that it's opening in Microsoft Excel. And it looks like we've got a simple little table. The upcoming few days, the projected high and low temperature for that given day, right? Where our first column here has the titles of, the first row has the titles of each column. And then each row is, a given day. On March 16th today, the high is supposed to be 48 in Chapel Hill and the low 39, right? You can imagine that working with data like this is something you would commonly need to do in a program. So how do we get our data from something like Excel into Python? Well, there's a special way that we can save this type of data. And if you were to open Excel or Google Docs or Google Spreadsheets or Numbers in Mac or any other database, they're going to have the ability to save as what's called a comma-separated values file. So CSV is an acronym that's short for comma-separated values, right? And so normally when you save files in a program like Excel, there's a special kind of file that's very specific to Excel. Well, you can also save files as other data types. And the one that we're looking at that's very common when you're sharing data between systems or needing to process it programmatically is a CSV file, comma-separated values. So why is it called comma-separated values? Well, if I look at this file in VS Code, you'll see that there's some similarities to what we just saw in Excel. Notice that it's plain text. Like this is just text like we write in our program files. There's nothing, we can't bold any of this. We don't even see lines between the tables. It's just characters that we could type ourselves. And in fact, I'm going to have you replicate this in just one moment. And each row of our spreadsheet becomes a line of text in this file. And each cell or each column is separated by a comma. And that's where the name comes from, right? Comma separated values. Well, today, the second column in this row is the high of 48 degrees, right? So what I'd like you to do in your VS Code is in your COMP110 workspace, if you want to go ahead and collapse or minimize these directories so that you see all of your directories listed here. And if you use the right click button and select new folder, or if you hover over up in the top here, you'll notice there's this new folder button. If you click that, and let's add a folder named data, right? And in this folder named data, I'm going to add a new file and name it weather.csv. Okay? And I'm going to copy and paste from my example here, but I'm going to give you all a minute to go ahead. And in your weather.csv file, go ahead and try and replicate this data file that you see here with the 4 rows. And each of these characters is a comma, just like you would type. And you can, if you don't want to use these values specifically, you can make up the numbers, but be sure that you have 3 columns per each row, and a few rows worth of data. So I'm gonna give you a minute to replicate this, and I'll pause here and we'll come back and look at how we can read this data in VS Code in our Python programs in just one moment. All right. What we're about to do is read this file, the data of this file, into a Python program that we'll write together. And in doing so, we're going to need to open this file in our program and then loop through each of its lines and process them in some way. And it's going to turn out that dictionaries are going to be our friend here. So one of the reasons, and what good question that came in, is what's the point of dictionaries? Well, when we go and read each line of this file, we're going to get back a dictionary for a single row where the keys are going to be the column names and the values are going to be the associated values for that given row. And we'll be able to do this for each line in the file. When we start reading files from our file system, if for some reason you put the file in a directory that was maybe not quite right, you might get an error when you go to run the program that we're about to write. And if you are running into technical difficulties during today's lesson, please stop by tutoring tonight and we can work with you on that. So now that I have this data file, and hopefully you do as well, let's go ahead and set up a new Python program. I'm going to name this ls17 csv.py. All right. And let's go ahead and set up a doc string. I'll try and keep this CSV file if for some reason you are just a little bit still filling in this data. I'll leave it over here on my screen, but feel free to pause and resume as needed. The title or the doc string of this program will be example reading CSV files. Right. One of the first things that we'll need is to import some capabilities. Just like when we've needed to generate random numbers, we had to import some functions from the random library. Reading CSV files isn't such a common task that Python's decided this is a built-in function that's available without having to import it, but it is standard in the Python ecosystem. So wherever you have Python, you can import what we're about to and it will be there, but you do have to add this import line. So we're gonna have to import from the CSV package in Python. We're going to import the dictionary reader type. So a dictionary reader is going to help us make it much easier to read this data in row by row and give us back a dictionary for each row that we have in our data file. All right. When we're working with reading files, we're going to need to open a given file on our computer and close that file when we're done with it. So let's go ahead and set up what we're going to call a file handle. And I'm not going to type this variable quite yet. I'll show you why in a second. But we're going to let Python just implicitly decide what type this is. It's going to be a file handle type. And open is a function that is a built-in. Python says, it's so common that people want to open and read and write files in your programs. Let's just make this a built-in function. So that's why we didn't have to import open. So what are we going to open? Well, we're trying to open this file, right? Weather.csv. And this file is stored in our workspace in the data directory, and the name of the file is weather.csv. So I'm going to use a string name here, and I might make my text just a little bit smaller so I can fit this. And the string is data, that's the directory name, and then slash is what's going to separate the directory name from the file name, weather.csv. right? Now there are a few other options. I'm going to go ahead and close this, this data for now. There are a few other arguments that we need to provide to this function, the open function. These are a little bit cryptic. This R string is short for we're reading this file. We're trying to read this file. If we wanted to write a program that saved contents to a file, we would use W for write. But a long time ago, back in the 70s, people decided, you know what, the string R is going to be used to read files. So we're going to use that. And then we need to specify the encoding of our data, right? And so this is a little bit funky. This is a funky looking argument. And the encoding is UTF-8, right? Files can be saved in different encodings. We've learned a little bit about UTF-8. It is the character set that allows us to have emojis and kanji and other glyphs of languages such as Arabic glyphs, and it allows, you know, a much broader character set than we would have in ASCII, which we looked at, which was sort of the old original standard for English letters and other characters. Because files can be saved in different kinds of formats, it's helpful to specify that now we're working in UTF-8. Sometimes you don't have to do this, but it's good practice to do it. So you're probably wondering, how would you know to do these things when you go to write a program on your own? This is one of those things where, you know, when you need to go and figure out how to open up a file in a programming language, you'll typically, you know, search, you know, open a file in Python, or open a file in C, or open a file in some other language, and be reminded of some of these specific nuances of how you would work with files for reading and writing and so on. So I'm waving my hands here a little bit. You know, our concern isn't too much about these specifics. When we go to read files, we'll let you know that it's going to work in a very similar way. If it works in a different way, we would tell you how. If we hover over this open, what we see that it returns a type. This is a function that returns a type called a text IO wrapper. And if we wanted to be very intentional about our types, we could add that here. I feel like it's kind of noise. We're going to trust that when we open a file that is using the built-in, that we're given a file handle that we can read from, and we need to close that as well. So if we file handle.close, there's a close method that when we're done reading or working with file, we should close it. This is just good bookkeeping and practice. When you take something from a system, you should put it back where it belongs. And so when we ask for a file handle, we want to read this data. When we're done with it, we're going to close it, and that frees up some resources on your computer, right? Okay, so now we want to actually read this data. We're going to use this dictionary reader as a way to more easily read each of these lines of that file, you know, line by line or row by row. So let's go ahead and set up our dictionary reader. I'm going to say CSV reader is dictionary reader. So we're constructing a dictionary reader, and we give it the file handle, right? Now again, there's some steps here that are effectively what we're doing is we're opening the file, saying, hey, operating system, I'm trying to read a file. And then we're getting a little bit more specific, saying, I know this is, you know, a CSV file, and I want to read each row as a dictionary. And now that we've done that, what's really cool here is we can say for each row, so this is a for in CSV reader, we can print the row. And what this is going to do, when you use a CSV reader in a for it's going to move through each line, use the first line, the header, to figure out, okay, these are the keys. And then each row, it's going to give you back a dictionary where each of the keys is the column name and the values is that particular column value. So let's try printing or try running this program really quickly, and then I'll take a look at the questions. All right, so notice each of the rows of that file, data weather.csv, is printed one by one, but it's not in the same format, right? This isn't CSV format. Notice that each print statement is one of those rows, and we're given a dictionary back. So this is a great use and a great example of why dictionaries are useful. Here, when we're working with CSVs and we want to read a data file, if we set up the processing of that data file in this way, each row will be given back to us as a dictionary. Right? So hopefully that gets to one of the questions, which is, what is the point of a dictionary? This is one example. There are many more. It is a very useful and sort of a bread and butter data structure that you'll find in many programs. All right. Great. So this is us reading each of these rows of the data table one by one and printing them out. What if we wanted to store all of the data in a CSV file in our Python program in, say, a list of our rows so that we could have the complete table in memory that we could go and work with it later? Let's try setting up a table where the table's type is going to be a list of dictionaries where the key type of the dictionary is a string and the value type is a string. And this list will initially be empty. All right. So if we make a note here to say a table, and I'm going to put some quotes around this because there are different ways of modeling a table. We'll see as the semester rolls on, can be modeled as a list of rows where a row is a dictionary with the column title as the key, right? There's a great question that came in, which we'll actually have to address here in a moment. What if we wanted to find the average max temperature in our data set? Well, Dictionary Reader isn't going to assume or read any more into our data than just to say, okay, we're dealing with textual data, so I'm going to give you back strings, and then you can go and change those string types into floats or ints or bools or whatever you want, given the representation of your program. So yes, when you're using a dictionary reader, you're going to have your rows are going to be modeled as strings to strings, even if there's other kinds of data in there. The second step would be going and converting your values to their specific types. So we'll take a look at that in just a moment because we're going to have to do that to figure out the average max temperature. But let's go ahead and add each row to our table. So table.append and then our row. All right. So notice, table is a list. What is it a list of? Well, it's a list of dictionaries where each item in our list is a row. And for a given row, we can look up a value by the column name, right? So now that we've, add each row of data to our table. After we've done that is a fine point for closing our file. We're done. We've read all of the data into this table. And now we can, if we wanted to go find say the average max temperature, we can do that processing after the fact, right? But let's go ahead and just let's convince ourselves that the table is indeed a list of dictionaries. We could try printing that table. Right? And let me clear this. So if I were to run this, notice that we have list literal syntax. So we have those square brackets, and then our curly brackets show a sequence, or each item is one of these dictionaries, right? So sure enough, it looks like we now have in memory a list where each item is a row, right? There's a question of how come on line 10 right here I used square brackets instead of curly braces. That's a great question. So notice that the type of table is a list, and this is a list literal. Well, when we type a list, in the type of that list, we're saying each item in this list is going to have this type, which is a dictionary of string to string. So if I wanted to, initialize our first row here, I could have said something like, date 3/16. I think the high was the next column, and I could make up a number, right? That'd be very cold. And so notice that because we're saying table is actually a list of dictionaries, and each of those dictionaries is a row. That's why we're initializing table to be an empty list, right? So this is the empty list literal, just like we talked about in the previous lection. Is row implicitly understood by the computer? So again, just like within any for in loop, we can name this whatever we'd like. So we could have named this entry, and I could have called it entry there. I'm going to leave it as row for now. But what you can expect when you are looping over a CSV reader is that each time this loop runs, you're going to have the next row of data assigned to whatever variable name you chose for that particular for in loop. So in this context, because we're using this dictionary reader, it does know that each time this loop iterates, you're getting back the next row of data. All right. I don't understand how these keys are unique because date, high, and low repeat with different values attached to them. That's a great observation and great question. Let me try and illustrate this really quickly. So the way to think about what's happening here is imagine we've got our table, and our table refers to a list of dictionaries where each dictionary is from string to string. Our keys are strings and our values are strings, right? The first time we add a row, what we're doing is we're saying at index 0, add a row. Well, what is that row? Well, it turns out that's a dictionary from string to string where the date is 3/16. I'm not going to put quotes around these, but these are all strings. The high temperature is, I think, 56 or something, and then the low is like 36 or something, right? So that's one dictionary, and that's one row. Well, the next row that we read of data in is going to insert another entry into our list, and that's going to refer to another dictionary, right? So as you can imagine, we're going to actually have, for each row in our data set, we're going to have a dictionary. So each row gets its very own dictionary object. And there's no problem with having two different dictionaries that have the same keys, right? It's only within a single dictionary that this would be a problem. So this was like the 17th, and this is a really ugly diagram. But you can imagine once we add that third row, there's a third dictionary. So each time we read a new row, we're getting a new dictionary. And it just so happens that all of these rows do have the same keys, but they're distinct dictionaries from one another. Great question. Just to close out this last open question here, could you have two different dictionaries with keys of the same name, but different types? Within a single dictionary, so yes, rereading that question, yes, and that's in fact the scenario that we're working in. We've got many different dictionaries, and within those individual dictionaries, they share the same key names, and that's actually pretty handy in this case. All right. Would open and close have an impact on the diagram? Good question. Because what we're doing here with opening a file using this built-in function and closing it, technically these are function calls and method calls, and they would impact the way a diagram works behind the scenes. But we're never going to diagram open and close in a diagram because it's we don't have the code to look at to know what we would add to it, is one way of thinking about it. So we're going to use this in practice, and it has many real world applications, but we won't diagram file handles in our program because it doesn't really add to the diagram discussion. And so you don't need to worry about diagramming open and close in files. We will diagram dictionaries, and just like lists, because they're mutable, we have to be careful about how many references and where those references are. Yes, dict reader only works with stir. So let me try and bring this example home by seeing, okay, well, what if we wanted to find the average max temperature or high temperature of a given day? And then I'll take questions to close out. So we've got all of our data is read into this table, right, which is a list of rows. And now what we want to do is, well, we're focused on a specific column. And we know for our purposes that that column is storing floating point values. So let's go ahead and set up a variable that will allow us to store all of those values as floats. Right? So maybe I'll call this high temps. And this is going to be a list of floats, right? And it's initially empty. So if we wanted to add a comment on what are we trying to do here, let's calculate the average high temp. What we'll do is we will process the table by a specific column. This is a common strategy that we'll see throughout the rest of the course. Oftentimes you're focused on a specific column because you're going to have data that's of the same type, and that's typically where you're doing some analysis. All right, so how do we actually populate this list? How do we get each of our values out of our original table and into this list of floats? Well, let's loop through for each row in our table, right? So the row is going to be the next dictionary, the next dictionary, the next dictionary. And we know that because our data file had, let me just open that back up really quickly. Because our data file has the column name date, high, and low, we're focused on this high column. So what we're going to do is we're going to say, okay, high temps dot append. And what are we trying to append? Well, we have this row and we're looking up its high value. But we see that we have this problem. When we read this data in, we have it as a string format, but this list is expecting floats. So what do we need to do? Well, we need to convert it to a float, right? So we use that float function. And now if we were to run this, high temps would be a list that has these floats loaded into it from that given column, right? So I can print high temps. And I can try running this, right? And notice that we have 48, 63, 72, and those are the values of this column that we're working with, right? So what we're doing is after we load this data file into memory, which we did right above, then we're going through each row one by one and accessing the value that's stored in the high column for that given row, converting it to a floating point and appending it to our high temps list. So now if we wanted to just finish this out, we could print the average high temp was, and we could compute this with a variable. So average high is going to be a floating point. And we know that there's this sum built-in function that we can use. We can sum up high temps. That will give us the total, and we want to divide that by the length of high temps. Right? And then we probably want to print this out. Oops, I've got accidentally pasted something there. There we go. So the average high temp in the data set that we provided was 61. If you were to go and add additional rows to your CSV file, notice that's completely separate from our Python program here, you would get a different average computed. There's a question, is the first row in the data file always the column names? If you're trying to use a dictionary reader in this way, which we will be in this course, that is the expectation. There are ways of working with CSV files that don't have header files or don't have a header row. And in that case, if you search around for processing a CSV file in Python without headers, you'll find alternate solutions. When you do have headers, though, it's very handy to be able to work with these rows as if they're dictionaries, and it's a great use of dictionaries. So is it possible to have a list of dictionaries and a dictionary of lists? What about a list of dictionaries and lists of dictionaries? How is it processed? Yeah, all of these ideas compose thanks to the ability to have references. So you saw me when we had a list of dictionaries, I can draw an arrow from the item to some other dictionary object on the heap. And it turns out you can go vice versa. You can have a dictionary where your value types are lists. You can have dictionaries where your value types are other dictionaries. You can have lists where your value types are other lists. So you can mix and match these ideas in very logical ways. And one of the skills of being comfortable with programming is learning how do you model a problem with some of these tools that you have available. And so these are two different ways of thinking about your data. Here we used a list to be able to use the sum function, and lists of floats was a very natural way of expressing here's the values for a single column, and we can analyze that with some algorithms. I want to point out that this is the end of our official lecture time. I'm going to keep going through some questions, but if you need to peace out, that's totally fine. Again, if you had problems, do stop by lecture or tutoring from 5 to 7 tonight, and we'd be happy to talk you through any of the concepts today. All right. Can you show your entire program? Yes, sorry. Let me leave that here. Sorry about that. I think that's I apologize for the size of that font. But if I make it any bigger, there will be some scrolling. But this is the program in its entirety. All right, well, these were fantastic questions. And in the next project, we're reading this paper on police traffic stops. And what I should show you is if I were to search for Stanford policing website, and this is linked to from our reading, you'll notice that there's a page on data. In fact, it's one of the top level navigation items. And you'll see that there's a way to download data. And when you scroll down to, say, North Carolina, we'll see that some common cities that we know of are in their data set. And you've got in download 2 different file formats. I actually don't like the way they designed this. I wish they had made this what looks like a page, the letter C or something. But it turns out the page icon, if you notice when you hover over it, it's tiny here, but it says download this data as a CSV. And so you can access all of the data in the paper that we are reading in the CSV file format. The R format is for a different programming language called R that's very common in statistics. And so you'll see that, wow, these are some large data sets. If we look at the state patrol data set for North Carolina, there's going to be 20 million rows in that CSV file. So this is going to be a pretty massive data set compared to the one that we typed out together here. And this is where we're going with these new capabilities. We'll be able to read these data sets row by row and then analyze them and look at some of the features in the way that the paper does. Right? So this was a quick lesson on dictionaries and CSV files. And with these 2 tools in our arsenal, we'll be able to do and take on some more exciting data processing programs in the weeks ahead. Great work today. And we'll have an async day on Thursday where we introduce some new tools, and we'll have everything we need to know in order to get going on the project that allows us to analyze this policing data. All right. Have a great rest of your Tuesday, and I'll see you asynchronously on Thursday.